Hi, I'm Tyler, and in this video segment we'll be exploring Google Colab notebooks and how they can be used to access Earth Engine's data and analysis capabilities. So let's get started. First off, what are notebooks? Notebooks are a standard format that is part of the Jupyter project's open standards for interactive computing, and they are widely adopted in the data science community. Notebooks promote the idea of literate programming, which combines computer code with contextual descriptions such as formatted text, images, equations, hyperlinks, etc. The code in the notebooks is live, meaning that it can be interactively run to produce rich outputs that live within the notebook. Notebooks can also be used for open, reproducible science. They provide a compelling mechanism for the easy sharing of these ideas. Notebooks also can provide access to Python packages. There's a wide variety of these Python packages that are available. Packages can process data that's returned from Earth Engine, opening up many new possibilities for analysis and visualization workflows. However, it's important to note that Earth Engine backend servers do not know anything about Python or JavaScript, so you can't send arbitrary Python code like NumPy, scikit-learn, to the Earth Engine servers. Rather, you need to build your own algorithms with the objects and methods that Earth Engine client libraries provide. Notebooks can also support workflows that integrate multiple external services. Notebooks can be used to interact with online services such as Google Cloud Platform products, Compute Engine, BigQuery, Dataflow, AI Platform, etc., and pretty much any other web service that provides a publicly accessible web API. So why Colab? Well, because notebooks have become so popular and because Jupyter project's open standards, there are many different environments for working with notebooks. And Google Colab is just one of these environments. Colab is a cloud service. It's always accessible, and you can just access documents by pointing your browser to a URL. Colab's features allow for easy collaboration. You can share your data on Google Drive or GitHub. That includes both the data and the notebooks, and you can also exchange these files with your local computer. Colab notebooks can be a great environment for communicating technical ideas that involve code. So to demonstrate this, I'll be using Colab document to introduce you to Colab. We're going to start by going to colab.research.google.com. And when we go to this URL, it brings up this web page that has a dialog box allowing you to select examples of Colab notebooks, recent notebooks you might have edited, or notebooks that you have stored on Google Drive or GitHub, or finally ones that you upload from your own local environment. But in this case, we're just going to click on New Notebook, and this is going to create a brand new notebook with no content in it. It's pretty blank here, and we can go ahead and add some code and text cells if we wanted. But to shortcut this along, I'm going to just open up a notebook that I have previously populated so we can see what it looks like here. So let me copy and paste that. And this is the way that you can share notebooks with others. It's just copying and pasting that URL. And if they have permission to open that document that you've given them using the share dialog box, they'll be able to open and work with the notebook just the same as you. Alright, so the notebook here has a series of cells on the side here. The first cell that we have here is a text cell, which has a little bit of information about the notebook itself, and interesting enough, a hyperlink here that's automatically generated. If I double click on the cell, it's a way to edit the content of the cell. And in this case, it's just a series of basic text, and at the end, there's a URL that Colab recognized as a URL and formatted it accordingly. And if I click on another cell outside of here, that one gets rendered. The next one down here is also a text cell, but if I click on this, it has a little bit of formatting markup here. It's got this little pound sign, which means that it's a first order heading. Colab uses Markdown as its styling language. So in this case, this single pound is a top level heading, and the next one down here, if I double click on that and explore it, it's got 2 pounds being a second level heading. Now these headings are really useful to use in Colab because they populate the table of contents over here on the left side, which you can collapse and expand as needed. And this table of contents allows you to skip around to different parts of the notebook. So I could skip down to basic example, to the Earth Engine basics, etc. It's nice for organizing your content, and it can be a quick way to jump around if you're trying to reach different parts of your notebook. All right, moving down a little bit farther, there's another text cell, and finally we get to our first code block here. And those are formatted a little bit different, or styled a little bit different, with a gray background and a little run button here. I can run this cell by clicking on this play button. There's a few other ways to run it as well. You can actually do it from the menu by saying run the focus cell. Or there's even a shortcut, which I really like to use quite often. And that's usually the fastest way to move through the notebook as you're doing this. All right, so I've run that cell, and after I've done that, it'll have a little indicator on the cell itself of the order that it was run in. So this is the first cell that was run, so it has a 1 there. Next we have another text cell here that's showing off a little bit other annotation type. That in this case we have some mathematics. You can edit mathematics using MathJax and LaTeX as a formatting language here. So you have to usually look up basically what the rules are of formatting that, but it's a standard language and allows you to get mathematics into your notebook as well. And finally we have one more code cell here. It's going to take actually variables that were set in the first code cell and then make use of those to print out an output here. So one thing that you'll notice already is that you're able to interleave this code or annotations of the code with the code itself. And in the background, Colab is connected to a virtual machine that is running a Python kernel, which allows variables to be updated and propagated throughout the notebook. You can get some information on that virtual machine up here by rolling over here. It tells you how much RAM is available, how much disk space is available on here. Colab's virtual machines are transient, meaning that if you go away for a while, it might get recycled and you have to request a new one. So you can't, if you're doing something over a long period of time, you have to make sure that you're saving your work somewhere where it's not just going to be recycled with the virtual machine. All right, moving down a little bit farther. By default, you have a lot of the standard Python packages and a few extra packages that the Colab team has installed into the virtual machine. But if there's a Python package that you want and is not available, you can install it by using commands like this. In this case, it's going to run a shell command that's going to install using the Python package index, pip install xkcd. We're just going to use this as an example one of installing to show you what it looks like. Alright, so it's going to reach out and pull the xkcd package into this virtual machine and install it. It says it's done so successfully. And then once we've done that, we can actually run the next cells that are going to import the xkcd library, for example. I'm going to import a few other ones, these IPython display methods, HTML and image, because they're useful for displaying some of the results that we're going to use here. Okay, now next, this cell is going to actually make use of that xkcd object that has been imported, and we're going to use a method in here called getRandomComic. And if I click on that box and I roll my cursor over the method here, getRandomComic, it's going to give me some information about the definition of this method. So if I roll over there once again, I get a little bit of help information about this method that's there, what it does. And if I do the same thing going over the xkcd, it'll give me information about that level of object, or in this case, the module xkcd. So it's really nice to get that context-specific help as you're going around. Anyway, I'm going to run this code, which is basically going to request a random comic. And when that comes back, it prints it out. And this comic object basically says the comic is for a certain link, and I can click on that if I want, and it will bring me out to the xkcd comic strip for some random comic here. Alright, so if I go back in, I can do a few other things with that comic object. In this case, I'm going to request the get image link. And let me show you one neat thing here, is if I get rid of that method right there, and I put my cursor at the end of an object, and then I start typing, like, what are the methods here, it's going to give me a list of all the different ones that are the one I wanted. Alright, so in this case, I got the image link, and there it comes down below there. Alright, next thing I have down here is a little cell here that is just going to print out a little bit of information. You can actually make these code cells so that they hide information, so it's only displayed when you actually run it, which can be useful if you're trying to use it in like an educational setting, asking a question that you want the student to work out before they see the answer. All right, the next section that I wanted to show off here shows an additional rich text element, the iframe, so that you can display other web pages within your notebook. So in this case, it's got a bit of code that actually has a URL for a Google Slides deck. And so we have the URL there, and we're going to display that in an iframe, and below that HTML information on where it came from. So let me run that, and this populates up a thing here. Let me close down the navigation here so we can see it all. And in this case, we have a slide deck that I was using earlier. And I was going to use this to talk about, how the Colab goes through the Python client library, and it's equivalent somewhat to how the JavaScript client library works here. All right, so that was a brief overview of Colab notebooks, how they work in general. So let's get into now a little bit of how they can work with Earth Engine. So I have a new section down here, Earth Engine Basics, and get my navigation back up there. And starting off with this, we're going to import a few libraries that are useful for working with Earth Engine. The first one is the Earth Engine Python library itself, the client library, or import EE, and then another one which is Folium. Both of these libraries are non-standard for Python, but they are installed in the Colab virtual machine. So if you're running this code in some other Jupyter notebook environment, you might have to install both the Earth Engine API and Folium before getting this to run. So let me run that down here. And so we've imported those libraries, and now the first step that you always do with Earth Engine is to authenticate yourself to the backend servers to actually show that you have access to Earth Engine. So here I run EE authenticate. It gives me this set of instructions and a hyperlink here that I can use to complete this OAuth workflow. So you select the account that you're using. You read through and agree to certain permissions. In this case, it wants to view and manage my Google Earth Engine data and manage my data and permissions in Google Cloud Storage, which means that we can use it to actually write data to Google Cloud Storage, like tables and images and things like that. So I'm going to say allow. This gives me back a one-time use password that I can copy and paste back in here. And hit return. And then this one-time use password basically gets converted into credentials that allow this virtual machine to talk with Earth Engine. Anytime the Colab virtual machine gets recycled, you're going to have to go through the same flow again because it loses all the information about knowing that you can connect to Earth Engine. All right, after you have authenticated, next step is to actually ask the Earth Engine client library to reach out to the Earth Engine backend servers and find out what it can do today. So it returns a list of all the objects and the methods that the Earth Engine backend can make use of. So it changes kind of on a weekly basis sometimes. All right, the next thing that we have down here now that we've got set up with Earth Engine is we're going to go through a little bit of the analysis. We're going to first define an Earth Engine object, and one of the most common ones to use in Earth Engine is an image object. In one of the earlier segments, we went through how you can get these image IDs for different assets that are in the Earth Engine data catalog, and I'm going to just use this one, USGS SRTM, for a DEM that's in there. It's one of the basic ones. It's one of the simplest images that we have in there, that it basically has one band elevation. So it's pretty easy to use as a starting point. So I'm going to declare this Earth Engine image object with that ID, and now it's stored in a variable called DEM. I can print out information about that object by just using the print statement, and in this case it prints out the metadata for the object on the client side. So it's saying that it's an Earth Engine object and it has a certain ID that I passed in, and that it should load up the image according to that ID. So this is on the client side. It actually knows nothing about the data or what the image even looks like at this point. You have to send it off to the Earth Engine backend servers, and there's a variety of ways to request data from the Earth Engine backend servers. One of the most common is this get info call that you can apply to an object. So we're basically saying this Earth Engine image object called DEM, let's get the information on it. And as I run that, it's going to return a Python dictionary that has quite a bit of information in here. It's got, information on the bands. In this case, it's a single band called elevation. Also has metadata on the image itself, who the provider was, some visualization parameters that you might use to get started, etc. Any of this stuff in this Python dictionary you can use in your Colab notebook as you go along, so you can use the metadata in your algorithms. Alright, the next section here goes over how to display this image in the notebook itself as a static image. So if you're familiar with a code editor, you've probably seen these visualization parameter sets before. In this case, it's a Python dictionary, but it's going to define what bands we're going to display, the min and max range of what will be considered to be the upper and lower bounds, and then a palette of colors. And then I'm going to call basically this visualize method that takes all of these parameters and whatever the image object is and produces a 3-band representation of RGB representation of it. And that can be displayed in the notebook itself. So let me run this. It's going to reach out and get that global DEM representation of it using these visualization parameters. And that gets printed on the screen here. It's a static image. It's either a JPEG or a PNG, depending on how you requested it. And you can't really do much with it. It's just, it's a good representation of it. But a lot of images in Earth Engine are really detailed, and you want the ability to interactively kind of work with them. So the next section here is going to go through how to display an interactive map in a notebook. And this is going to make use of the Folium package, which is based on the leaflet JavaScript library that's available in Colab, this Folium package. But in order to use it, we have to basically teach it how to display an Earth Engine layer. So I have a cell here that defines a method here that adds an Earth Engine layer to a Folium object. And then once I've defined this method, I'm going to add it to the Folium map object here on this line. So this is sort of teaching it how to display an Earth Engine image. Once I've taught it how to do it, I then can go down and make use of that in the next one here. Looking through the code here is like I'm going to create a Folium map centered on a certain lat long and a certain zoom level. And then I'll add that Earth Engine layer to it, doing a little bit of manipulation here just to make the oceans look a little nicer. I'm basically going to mask out the stuff that's less than 0. And this makes a interactive map that you then can zoom around in. And I always like to check things out by going to the Grand Canyon, because I just like the way that renders. But this is the basics of how you can get your Earth Engine data, your tiles of an image object into Folium. And Folium is a full-featured mapping package that you can add all kinds of other layers as well to it. Alright, so that's the basics of how you get through here. Oh, I see one thing that's over here on the side, which I forgot to clean up from one of my previous runs here, is a comment. When you are using the Colab notebooks and you're saving them on Google Drive, you have some neat collaboration features that I was going to discuss down here below, but one of them is the ability to comment. So you basically can leave comments for any collaborators that have access to it. Something like this, and whoever else is opening up this notebook and looking at it will have access to the same comment features that you have here, and you can resolve and have a little discussion about your notebook and your code within here. Alright, so that's comments. That is when you're saving this information on Google Drive. But there's other ways that you can save notebooks as well. You can save them to GitHub either as a short GitHub gist, just a very small single file, or you can save them to GitHub as part of a larger repository as well. And you can find those options under the file menu here, and there's different save as options in here. Alright, so there's a lot more to explore in here. One of the amazing things about Earth Engine and the client libraries that we have is just the sheer depth of it. For example, if I wanted to look at what you can do with an image, I can run this dir that gives me all the properties of like an Earth Engine image object. And if I, scroll back here and scroll this down here, There's all kinds of different things that you can do with an Earth Engine image object. And each of these are documented in our documentation. They all have different parameters. There's all kinds of different building blocks that we can use in the Python Colab environment, the same that we can do in the Earth Engine code editor, but in JavaScript. All right, so that's all I wanted to do in terms of showing you off what you can do within Colab, just as an introduction. And we'll do more in the future, looking at different aspects of Colab and how we can use that to actually run Earth Engine algorithms. In this video, we've really just touched the surface of how Colab and Earth Engine can be used together. To dive deeper into any of the topics that were introduced, explore the links that accompany this video. We'll also be exploring additional features and workflows in future videos. Well, that's all for now. We look forward to seeing what you create.